Recall that the orange data points here are the photosynthetically active radiation that's incident on the Earth's atmosphere. For the purposes of this quality assurance, those are not data points necessarily that we're interested in. We're using them as setting the boundaries of where we would expect solar radiation to fall. So during the day, it should be somewhere between 0 and this line as a maximum value, other than some values that might be high because of diffractive focusing of the solar radiation. So maybe it's better for the symbolism on these figures to where these are a shaded area as opposed to data points. That might make more sense. So let's talk about how we might represent the solar radiation incident on the atmosphere as a shaded area as opposed to data points. If we go back to our code, you can see that we have our plot of data points right here, and we're plotting these first because we want to plot our measurements on top of them. So we want to replace this code that's putting points on the graph with codes that will put shading, or in this case, a polygon on the graph. So instead of points, we're going to use the polygon function. We're going to need the same x and y axes to define the polygon. So our x coordinates are the time, and our y coordinates are the PAR data. In this case, the PAR that's coming from space. And just like the data points, let's make the color here orange of the shading. And in terms of polygons, you'll have the color of the polygon, but you'll also have a boundary of a polygon. But in this case, we just want the shading. We don't necessarily want the boundary. So we're going to set the border argument that lets us control the border, the type of border, and give it an NA value to say that we don't want a border. Sorry, it should be spelled border, not boater. Okay, so this should make a polygon instead of the points, but using the same data points. So it should be shaped like the data points. Let's see what this does. So now instead of data points, we have these polygons representing the range of solar radiation we ought to see on each day. And those ranges increase with the season as you go toward the solstice from March, as you might expect. Now, one thing you have to be careful with polygons is making sure you understand where your data points are stopping and starting. Because what R is going to do in order to enclose a shape and then shade the enclosed shape is it's going to draw a line from wherever you stop back to where you started, and then enclose whatever's enclosed by that line. So you can get some weird behavior. In this case, it looks okay because we're starting and stopping at values that are very near to 0. But just to illustrate how this can be an issue, let me go back to the code. I'm going to go back to where we set the start time. And what I'm going to do is I'm just going to add some hours to this. Let's say we'll add 8 hours of time to our start time. And that means our start time will be at a time when the sun is up, and we'll have non-zero values for radiation. Let's see what that does to our graph. So now we have this sort of weird shape because we've drawn a line from where we stopped back to where we started, and it's filling in all the space between our data points and that line that we've created. So we have values that are above that line that are filling in the days where we expect, but we're getting the opposite part of the graph being filled um, below that line. So this clearly isn't what we want. And just to be sure that our graph looks well no matter where we start our time, let's go back to our code. And we can get rid of that problem by making sure that our very first and very last data point that we're graphing with our polygon are 0 values. And we can do that by saying that our weak par space has 0 values for the very first and the very last element. So we're going to index this vector with 2 values representing the first and last element. The first element is just indexed with a 1. The last element is going to be whatever the length of this vector is. So the length of the vector is going to be the same thing as the index of the last element. So we're taking the first and last element, we're indexing our weak parse space vector with those values, and therefore if we assign both of these to 0, that should fix any problems with our polygon not filling up the correct part of the space that we want to represent. So I'm going to rerun again, and we can see how this changes things. And you can see how that fixes the problem. Even if we start at a time where there is daylight on our week, we still are cutting off a value that's ending at 0 for our last data point and being drawn back to 0 at our first data point, and therefore it's filling in the part of the polygon that we want to fill in to represent PAR, or solar radiation incident on the Earth's atmosphere. Ultimately, that was just for a quick demonstration. We don't really want to start time. So we need to go back. We don't want to start time at that time of day. So we want to go back and get rid of this 8 hours that we added. And after running this chunk one more time, we should be back to where we were originally. It doesn't look any different, but now we're sure that our first and last data points are set up in a way that we will always make these polygons in the right shape, regardless of where we start.